Welcome back. In this video, we're going to talk about visual presentation of data, and we're going to focus on quantitative data specifically. So here's an example. I asked 65 students, how many hours of sleep on average do you get per night? And here I have some discrete quantitative data. Now, this is a small data. It's small in that the values themselves are small. I think the highest value that I have here is 12, and the smallest value I have is 3. So the range of the values are small, and I also have a lot of values in for each category, for most of the categories. I think I have only 1% for 3 hours of sleep, maybe 2, but and 1 for 4, but pretty much all other values I have a lot of frequency for each of those values. So for small quantitative data, small discrete quantitative data, you're gonna handle it the same way we handle qualitative data. That is, we're gonna do tally marks, construct frequency distribution, and then construct a bar graph. But it's actually for the quantitative data, we're going to use a histogram. But let's take it one step at a time. So here's my data set, and I'm going to create a frequency distribution just like before by listing all of the values from smallest to the largest. So our smallest value is 3, and our largest value is 12. So I'm gonna list all of the values in between, not skipping anything. And then I'm gonna put tally marks, which will tell me how many times each value is occurring in my data set. So here we are. I finished doing the tallies, and I wrote them out as frequencies. Now, notice that for 11 hours, I didn't have anything, but I didn't skip it. So for numerical values, it's very important to list all of the values, even if you don't have anything for this specific value. So for the frequency of that row, I put 0 in there. So in order to make a chart just like before, I'm gonna list my values on along the x-axis. So I have from 0 to 12, and then I'm gonna list my frequencies or relative frequencies on the y-axis. I'm actually gonna go to the software to finish this process for us. All right, so I have my StuckCrunch here, and I have my data entered into the first column, and then I can go to graph. And notice that here we have a choice of doing a bar plot or a histogram. So normally for quantitative data, we're going to use histogram. But let's just see what happens if we select bar plot for this data. All right, so here's our bar plot. I did something that became colorful. Yeah, I selected something that I had to deselect. So now we have our bar chart. So yeah, we have our frequencies. It shows the distribution. We know that the most frequency that we have is in for 8 hours of sleep. The next to it is 7 hours of sleep that has a frequency of 16. But notice what happens on the x-axis. So remember we had a frequency of 0 for 11. So it doesn't show 11 on that number line. And we know it's wrong, right? Because we're talking about numbers. But because we selected a bar plot, it thinks the program thinks it's qualitative data, so it doesn't treat these numbers as numbers, it treats them as labels. So let's go ahead and fix that. We're gonna do a histogram instead. And this is what our histogram looks like. So our bars now are touching each other, so they're wider, right? And there are no gaps between the bars, and it's called histogram. And now our number line is complete. We have, there are no numbers that are skipped between 2 and actually 13. It extends to 13, and you see we have um, by 11 we have a frequency of 0. So keep that in mind. For qualitative data we use bar graphs. For numeric data we have histograms. So here's our next data set, and this is a discrete values, but large values. And I ask students, what is your height in inches rounded to the nearest inch? And I have 82 results below. Now, this is a large data set. How is it large? Well, first of all, the numbers are larger, but I think the main difference from the one that we saw before is that the range of this data set is different. So my smallest value here is 48, and my largest value here is 80, which gives me a range of 32 values. So I would have to basically, if I was doing the frequency table the way I did before, I had to list a total of 32 values, and that's a lot. So here's my stock crunch again. I do have that uh, data uploaded. And if I go to graphs and I ask this to do a bar plot, oh, it's not asking me anymore. But the first time I tried, it said there are a lot of repeated values of 1, frequencies of 1 or 0. Are you sure you don't want to group it? So basically what it says, when we just let me actually do this bar graph really quick. Oh, here it is. It says lots of unique numeric values for height. Want to turn on binning for this process. Binning means grouping, and we're going to talk in detail about it later, but I ignore it for now. And this is the graph that I get. So like it said, I have a lot of unique values, and it's kind of difficult to read. Again, I don't know if any values are missed or skipped, because again, it treats my numbers as labels. So a better way to be to deal with this type of data is to group it. So let's do it together. We're going to do it slowly together. And we're gonna do it slowly, step by step, and we're gonna apply these steps in the process. So let's take a look. So the first step that we have to do is we're going to decide on the number of classes that we want. So I had about, my range was 30. I would say I want about 5 classes. 5 or 6 would be good. All right, so the next step is to figure out your class width. By the way, those classes, they're also called bins. There's another name for them. Let's see, categories or bins. All right, so we're gonna, or groups. Now, we need to find a group width or bin width or class width denoted by W. And here's the way we're going to do it. We're going to take the maximum value, subtract the minimum value from it, and divide by the number of classes that we want. Then if, now W doesn't have to be a whole number, but one thing to remember is that if you decide to round your class width, you have to round it up. Okay, so otherwise you're gonna end up with a greater number of classes that you originally wanted to. And if your W becomes a whole number, then you still have to increase it by 1. Okay, so let's go ahead and do that in our example. We have to identify our smallest value. Our smallest value is 48, and our largest value is 80. We have a bunch of 80s here, and choose each one of them. So W is 80 minus 48, and let's have 6 classes. So divided by 6. And I got 5.3 repeated. So it's 5.33333. Remember, we always, when we always round up. So I'm going to round it to the nearest whole number, which is going to be 6. So my class width is 6. So now let's create our table. I'm gonna write down my smallest value, and this is gonna be my lower class limit, or LCL. And that number is 48. Now my first group is gonna be 48 plus 6. So 48 plus 6 gives me 54. So my upper class limit for class 1 is going to be 54. So in this class, I'm going to have values from 48 to 54. Now my next class will start with 54. I'm going to write down 54 and add 6 again. So that gives me 60. So my second class will be from 54 to 60. The next one is 60 to 66. The next one is 66 to 72, 72 to 78, and finally 78 to 84. So now I have 1, 2, 3, 4, 5, 6 classes, and all of my values are accounted for from the smallest to the largest. My largest was 80, so it's gonna fall into the last class. Okay, so next we're gonna do tallies for the number of values in each class. So I'm gonna go through this data set and put tallies in each class. So for example, 67, this is my first value, where does it go? Well, it goes into class number 4. So I put the tally mark there. And now 59. 59 fits into this class, number 2. So I'm going to put a tally there. I'm going to continue this process until I basically account for every piece of values. Now, one important thing to note here is that your range of values in each class, it includes your lower class limit and goes up to, but not including the upper class limit. Okay, so if we come across number 54, it's gonna go into the second class and not the first class. So each class is not including the upper class limit. So the values go up to, but not including the upper class limit. So here's my completed table. All right, so I have my groups and I have my frequencies. So now in order to graph this distribution, I'm gonna create a system of coordinates where, again, I have heights on the x-axis and the frequencies or relative frequencies on the y-axis. And I can actually, I'm gonna start with my lower class limit 48, and I can actually use this symbol to show that part of the number line is taking out. This is not a 0. I'm gonna start with 48, and then my next value is gonna be 54, and then 54 to 60, and then 60 to 66, so forth. I'm gonna finish it, and actually let me ask, and then I'm gonna put bars that correspond to the frequency. I need to put frequencies here as well. So that's how you create a histogram by hand, but let's ask our StuckCrunch to do it for us. Here we are. We're going to graph histogram, and then we're going to select height. Sometimes there is more than one column, so you have to select the one that you want to represent, the variable that you want to represent. Okay, so bins. We're going to put the starting point, which is 48, and then the bin width, we had 6. All right, and then now we're gonna hit compute. Anything else here? Well, we could mark this dividers. No, we could mark this to show the values above each bar, and hit compute. And here's our histogram. There we go. That's how we create a histogram. Okay, what else is important to mention here? Well, first of all, when we have a frequency distribution, we can also figure out the relative frequency for each class by dividing the frequency in each class by the total number of values. And I believe we had 82 values altogether. So 2 divided by 82 is 0.2439. So let's write it down. That's the decimal form. And if we want to convert it to percentage, it's 2.439%. The symbol percent literally means 1 divided by 100. So it looks like I've changed it but I did not, because basically what we have here is 2.439 times 1 over 100, which will bring me back to this form. So this is the decimal form of the percent. This is using the percentage symbol. So for the second class, our frequency is also 2, so it's going to be the same as above. I'm not going to waste your time on that. For the next one, we have 16 over 82. That gives us 0.195112, and that's going to be 19.51% of 512%, thousandths of a percent. Okay, so, and we're going to continue this process. All right, so this is what we got. And remember, on our histogram, instead of frequencies, we could have relative frequencies marked, and we would get a very similar chart. What else is important? Later in the course, in Unit 3, we're going to be looking for some numeric values of the data, such as average, most frequent numbers, so forth. So notice that when we have only the table, but we don't have the original data values, we don't know which values we had between exactly between 48 and 54. We know we had 2, but we don't know exactly which ones. Did we have 2 of 88s, of 48s? Did we have 2 of 54th, or anything in between? Could be anything, right? Well, not 54th. If there were 54th, they would go to class 2, but what about 53s? There could be 53s, both of them. We don't know, but we still would have to calculate the averages and stuff using just the table and not having access to the original data. So the way to go about it, or to go around it, is to basically treat all, like average all the values in this class and treat it as a representative value for that class. So that's where the class midpoint comes in. So the class midpoint is what it is. It's what it says it is. It's the midpoint between the lower class value and the upper class value. So for the first class is going to be 48 plus 54 divided by 2. Let's figure out what it is. So that value is 51. And then we're going to do the same thing for all of the classes, and we got the values 57, 63, 69, 75, and 81. So these values are going to be representative values for each corresponding class. Another thing that I want to point out here is that notice that the distance between 51 and 57 is 6. 57 to 63 is 6 again. 63 to 69 is 6, and it's not a coincidence. That's our class width. So far, we looked at how to organize and visually present the small discrete data sets and the large discrete data sets. So for the small discrete, we basically group by, it's a single value grouping. So each value is presented. And for the large discrete data sets, we have interval grouping. But they're very similar in many ways. We can think of single value grouping as a grouping where the class width is 1, as opposed to, like in the previous example, we had a class width of 6. So that's the only difference. Now, what about, you may ask, what about the continuous data sets with continuous data values? Well, the continuous data sets are organized in the same way as the large discrete data sets. So you will have interval grouping. The only difference is that you may get some decimal values instead of just whole values, as we saw in the previous example. In the next video, we're going to discuss other graphs.